Hello, IB11s. Let's continue the topic. Before we start our part two of the lesson, so we want to introduce a little bit of kind of background information about the invention of the logarithm. We will look at who was the person to propose, or we can say invent, the logarithm first. So anyway, it's here. In the late 16th century, astronomers spent a large part of their working lives doing the complex and the tedious calculations of spherical trigonometry needed to understand the movement of celestial bodies. So in 1614, the Scottish mathematician John Napier formally proposed the idea for a logarithm and the algebraic methods for dealing with the logarithms. It was said that Napier effectively doubled the life of an astronomer by reducing the time required to do calculations. Of course, John find, or we can say proposed a logarithm when he was looking for the inverse function of y equals 10 to the power of x. So we know this one in part 1 already. When we want to find the inverse, we interchange x and y. Then John Napier found that he got stuck in bring this y down and then represent the y in terms of x. So this reason he proposed a new symbol in order to bring this exponent y down, which is y equals log x in, okay, anyways, we put on the base in the base 10. So just 6 years later, okay, I don't know how to pronounce this guy's name, but anyway, this guy is a Swiss clockmaker, a maker of astronomical instruments, and a mathematician as well. Anyway, he was from Switzerland. He published a geometrical approach for logarithms developed completely independently from John Napier. So only 6 years away from each other. Okay, so both of them proposed the same invention. Here, common logarithm. So we know x equals 10 to the power y. So the invention, which is the new symbol logarithm, can help us bring this y down from the exponent. It's anyway log x base 10. This is a kind of very complex way to write a math notation. So if we have the base 10 in the logarithm, we also call this log common log. In this common log, we can ignore the base 10. Or the same words we can say is, okay, if we don't see any base in a log symbol, that means this one should have base 10. Okay. Here, there is a very important logarithmic identity, which is a equals 10 to the power of log a. How did people discover this one? We know x is 10 to the power y. This form is mathematically identical to y equals log x base 10. And I need to realize, okay, this y is the same as this y. So people find that why not use this one to replace the y in the exponential form? So if I use this log x base 10 to replace this y in the exponential form, so this one is still equal. So this reason we can get it x equals 10 to the power of log 10x, which is the same as this identity. So Here we just use another different variable, a, to represent x. But this one is exactly the same as x in this identity. Okay. So if we use another way to replace in both of these two identical identities, okay, we can derive another identity. What is another identity? So this time you guys also need to know that this x equals 10 to the power y. This x is the same as this x. So I also can use 10 to the power y to replace the x in the logarithm. So we find another identity, which is y equals log base 10 here. This x replaced by 10y, 10 to the power y. So y equals log 10, 10 to the power y. This is another identity. Okay, so right now we need to find these two log values without using a calculator. Okay, right now let's look at how to find the first one, log 100. So you guys need to remember, if you don't see any base in the logarithms, that means the base should be 10. Okay, how can we find log 100 base 10? What you can do is, okay, you have two methods. One method is I will let this one be y. So the logarithm value is a y value. So then I convert this logarithm value back to the exponential form. So it's 10 to the power of y equals 100. So the y goes back to the exponent. And we know a logarithm is the same as an exponent. A logarithm is an exponent, always in the exponential form. So this base in the logarithm is base. So in the exponential form, it's still base. This argument is the power value. So right now with this exponential form, we can solve the y value. We know, okay, 100 is 10 squared. So we can change both of these two sides to the common base. And both of them have base 10. We can ignore the base, and their exponents must be equal. So y equals 2, which means log 100 equals 2. Okay, so this is the first method. The second method is I can use the second identity. Do you still remember the second identity? If you don't remember, you look at your notes again. So it's y equals log 10 to the power of y. So this y is the same as this y value, which is the same as the log value. So what I will do is my log 10, 100. So for this 100, I will change to a power of 10, so which is 10 squared. So log 10, 10 squared, that means my final value is just this exponent in the argument, which is 2. Okay, so right now I want to show you how can we use the graphing calculator to find the common log values. And my TI-83 plus, okay, only can help me find the common log value. But with TI-84 plus, you guys can find any log values with any base. So right now, this one is a common log. So we can find the common log symbol. Okay, the function key for common log is here. So what I need to do is just press this key, log, Okay, let's continue. So log 100, I just press log, then put 100 in. Okay, so the calculator will give us the value too. So right now, let's look at the second one. First, let's find this one algebraically. So number 2. Okay, let's put this one back. So it's log, which base 10? The base 10 is ignored still. So this reason why I help you guys review how to represent a power of 10 with different values at the very beginning of this lesson first. So right now you guys need to know, okay, you can change it or maybe just wait. Okay, right now let's look at this part, the second one, which is, okay, so I will still let y be log, you know this one base is 10. Okay, here the argument is the fourth root of 100. So what you guys can do is change this one back to the exponential form. So y logarithm become the exponent with the base 10 equals the argument, which is the fourth root of 100. So right now I only need to solve an exponential equation. If I want to solve an exponential equation, the basic way is change both of them, both of the sides to the common base. We can change this fourth root of 100 to the power of 10 as well. So first it's 100 to the power of 1/4. Okay. So this one is the same as 10 to the power of y. So we change this one to base 10. So it's 10 squared raised by 1/4. So then, of course, this one equals 10 to the power y. So we simplify this exponent. So this is a power of a power, which is 2 times 1/4. It's 1/2. So 10 to the power y equals 10 to the power 1/2. They have the same base. We can ignore the base. Their exponents must be equal. So y equals 1/2. So this is the first method. The second method is we also can just find the value based on the log form right away. So we can change this one, 10, okay, change this argument to 10 to the power of 1/2. But if you want to show us how you can change this one to 10 to the power 1/2 one by one, of course, for sure to go for it. So this one actually is 100 to the power 1/4. Then I change 100 to 10 squared and then raised by 1/4. Based on the exponent laws, I multiply the exponents. So 2 times 1/4, 1/2. So log 10, then 10 to the power 1/2, it's 10. Oh, sorry, it just should be 1/2. So, okay, which is the same as this one. But here the red method is the identity method. So let's use the graphing calculator to help us check the solution. So it's log, okay, let's turn on this one, then log, the fourth root. How can we find the fourth root? So I will press number 4 first. Where is the fourth root key? It's in math. You guys will see number 5. It's the x root. So this reason why I put the index before I find this key first. So then I put 100 in. Then close the brackets, enter 0.5. Okay, so that's how we can use the graphing calculator to find the value here. So right now, we need to use the calculator to write the following in the form 10 to the power x, where x is a character for decimal places, which means I need to use a power of 10 to represent number 8. Okay, 8 equals 10 to the power what? How can I find this x value? So you guys know the second identity already. I use the second identity to find the log value. But if we go back to the first identity, oh, that's how I can change any number a to the power of 10. So a equals 10 to the power of log a. So here I will know my 8 is the same as 10 to the power of log 8. What is log 8? I only need to find a log 8. It's 0.903 blah blah something. Anyways, we only need to get 4 decimal places. So 8 is approximately equal to 10 to the power of 0.9031. 800, it's the same thing. We use the first identity. 800 is 10 to the power of log 800. So let's look at what will the calculator bring us for log 800. Oh, log 800 is 2.903. So anyways, I can convert 800 to a power of 10, which is 10 to the power of 2.9031. So 0.08, the same idea. This one is 10 to the power of log 0.08. So on the calculator, I can find log 0.08, okay, which is negative 1.09691 something. Anyways, 0.08 is approximately equal to 10 to the power of negative 1.0969. Okay, I know this one is pretty tough, but we just use the first identity to change any number to a power of 10. Okay, so let's look at how we can use the calculator to find log 20, and explain why log 20 equals log 2 plus 1. So let's use the calculator to find log 2. So it's log 2, which is around, let's keep 4 decimal places still, 0.03010. So let's look at what is log 20 then. So log 20 is around, log 20 is around 1.3010. So it's 1.3010. How about the log 20 equals this one plus this one? So we know log 20 is 1.0310. I can change this log 20 value 1.3010 to 0.3010 plus a whole number 1. And this value, based on what we find from log 2, it's just log 2. So I replace this decimal with log 2 plus 1. Oh, no wonder they are equal. Okay. Okay, right now we want to find x in the log expression. Log x equals 3. So you guys know if you don't see any base, this is a base 10. We want to find the argument in log, and you guys know this 3 here is the y value. What I will do is I will change this one to the exponential 4. So it's 10 to the power of y equals x. So right now my y value is 3 equals x. So x equals 10 cubed, which is 10 times 10 times 10, 1000. That's how I can find the argument value in the log symbol. The same idea as this one. Okay, this one is the y value. So my argument x equals 10 to the power of y. So my x value is 10 to the power of negative 0.271. Use the graphing calculator to help you. Find 10 to the power of negative 0.271. Okay, so we can find the value is around 0.536. So we keep 3 significant figures in IB course. Okay, logarithm is not an easy topic. I hope that you guys can spend a little bit more time to absorb the information that we talk about here. And if you have any questions, please let me know. Thank you.